So this right here is the LPM, or low power magnetometer. This is Roller's LPM, and we're planning on moving this to the Ellsworth Mountain to see how the solar eclipse will affect the Earth's magnetic field.
Okay, I said a lot of words there, so let's go through it. The sun can have storms called solar flares, which send streams of charged particles towards Earth. These charged particles get caught up in the Earth's magnetic field and follow the field lines towards the poles, which creates aurora. If you notice on this animation, the poles are where all the field lines are concentrated, so all the charged particles are streamed towards the poles, and it's the best place to install instrumentation to measure these solar flares. All these red dots represent an LPM instrument, and they form the British Antarctic Survey's LPM network. As you can see in this diagram, there is no LPM in the path of the totality, so we have to travel all the way down here to the base of the Ellsworths to install an LPM. This map shows all the fuel depots and the flight times that we use to travel really far into Antarctica. Half the season is spent putting in these fuel drums so that we can travel really far distances, like to the Ellsworths. I'll go into more detail in another video because this is incredibly interesting.
It's about 3 meters buried under the snow, but it's the only one we have at the moment, so we have to dig this one out to install it where we're going. The instrument consists of this logger box and a battery box at the bottom, and then connected to a magnetometer, which is on a wire which goes maybe 20 meters in that direction.
The poles act like a lens for space weather, as all the little electric currents caused by the charged particles are focused here. Any small little perturbation these magnetometers can detect, and this helps with predicting space weather.
This cable here is a magnetometer, and this is solid ice, so I now need to chip through all of this to get out the actual instrument. That's not going to be fun. So I thought I found where the magnetometer is, but it turns out it's just a big block of ice that the cable runs through.
I spent 3 days digging and could not find it, so I got the help of John Witherston, who will be replacing me as the electronics engineer, and we're going to try a smarter way of finding this LPM.
So you have an oscilloscope and a dual channel power supply going down to this cable,
all running off a generator,
which is connected to the LPM, which we're going to now wave a sheet of metal above, and all that powered by this generator. You can then look here to see where the LPM is.
Tell what it is yet? Tell what it is yet?
So we have a...
Okay, stop a second. Okay, carry on.
I always feel like a fool.
Got nothing.
Okay, so update. The LPM, which we're trying to dig up, we couldn't get up, but about a month ago I told them that we might not get this one out, so they sent one down. It arrived yesterday. And then I got told that the weather is going to be awful for the next week. And tomorrow is the only window I have to get out to this Eclipse site, which is on the 4th, and currently it's the 29th. So I've got 5 days to get out and install it.
LPM, just installed it over here. That box there is the logger, and about 10 meters to the left, the instrument is under the snow, ready to see how solar eclipse will affect the Earth's magnetic field and how all the charged particles in the upper atmosphere of the Van Allen belts will be affected.
There is a second site at this location, which is partly the reason why this was chosen, that needs servicing. It's called a UK ANET site, and it's like an isotropic rebound. Basically, as all the ice is melting, how quickly is the Earth's crust bouncing back up due to the lack of weight that's on top of it. The site uses a really accurate GPS and some clever mathematics to work out how quickly the ground is bouncing back up. The site had power issues, which we thought was the solar panels, but it's actually not. It's the receiver itself was shorting out inside. This is the antenna on the other side of the couloir.
Minus 15, we just spent the night here at the Mount John Eclipse site. The eclipse will be in 3 days. You can see the sun is looking rather misty. We've had a lot of blow come through. We're going to try and get north now to Sky Blue and then to Rothera and get out of this place. We'll see how it goes.
So what is space weather, and how can you forecast it? Well, all the satellites we have in outer space are really susceptible to solar flares, and there are people who actually create forecasts for outer space. Satellites need to be shut down during really intense storms, so these instruments are incredibly important. But this one's especially important because, as I understand it, charged particles can affect the accuracy of these satellites and actually change the timing of them, and these have to be adjusted by engineers who work for the satellite company. So by putting an instrument here next to the GPS receiver, we can then look at the noise on the GPS receiver and correlate that with when the eclipse was and how much activity there was. The eclipse will give us a baseline for when most of the charged particles are blocked by the moon, or so we think. But I'm just the instrumentation engineer, so if you're interested, I'll try and get an interview with the scientist and get more information. We managed to wrestle the 40-knot winds all the way back to Sky Blue, then to Fossil Bluff, then to Rothera, but all my camera batteries died, so that's kind of the end of this video. But I will do a continuation on this project and future projects that we have. I have a lot of footage, including what life on Rothera is like, how do you cope with the isolation, what facilities do we have, all the wildlife, including whales and penguins, and pretty clouds like this lenticular time-lapse I took this evening. Thank you so much for watching, and if you're interested in more, please consider subscribing.